One of the first things you see on most four-wheel drives in Australia is a bullbar. And when you're looking to buy a bullbar, you see all sorts of information talking about ADR compliance and standards. What does all that mean though? To find out, we're here with Chris Holt.
As these vehicles become more advanced, the window of packaging everything in has become a lot harder. ADAS, forward-facing cameras, parking sensors, and just recently we've got cross-traffic radars on either side as well. So all that modern technology is now making it a lot harder for us to develop.
So you're actually looking at moving goalposts, because as you say, these cars are advancing very quickly. What are some of the things you're looking at on the front of the car here that we can see?
So obviously we've got parking sensors, forward-facing radar, camera positioning, and then also we need to look at airflow, getting that air into the intercoolants, the radiator, the condenser, and all that stuff as well.
What about the actual design of the bar itself? Are there standards there that have to be met?
ADR 84 is obviously radius edges, so we've got to make sure that the edges aren't sharp for pedestrians. We also need to make sure that there's no large apertures. All that comes into play when we're designing the bars themselves.
And that's all done in-house here at Ironman?
Yeah, so basically when a new vehicle is released, we'll bring it here in our R&D department. We'll scan the vehicle, both bar on, bar off. We look at the angles of the radars, the sensors, the cameras, the ADAS. So once we've scanned, we'll start laying down, positioning the geometry of the sensors and making sure that they're fit for purpose, because obviously that has a lot to play with it. We can't just grab a sensor that is in the badge and then move it down here, because obviously that has an effect on the projected cone out. So we need to make sure that aperture is still maintained and we still keep within that OE envelope.
But once you've got all the sensors and the technology in place, it still has to comply with the crashworthiness of the car too. The car crash systems are very sensitive, the crash boxes in the chassis, all that sort of stuff. How do you work around that?
We need to make sure we comply with ADR 69 and 73. We do our own testing in-house. The testing itself, people think it is to check the strength or the rigidity of the bar. It's actually really designed for a low speed impact, not to detonate those airbags. We need to make sure that we don't deploy that airbag at the wrong time.
So, and you said that's speed related to 16 kilometres an hour.
Yeah, so it's a 16-kilometre test.
Anything below that shouldn't trigger off the airbag?
Correct. It's a real science and a mathematical equation where we need to make sure that the bar is strong enough to handle a kangaroo strike, those low speed shunts or blows, but then also be able to absorb that energy when there is a high speed impact as well. What's quite scary when you think about it, there's a lot of bars in the market these days, and the ones that aren't tested, you're putting your family's lives at risk using a non-compliant bar.
Is it safe to say everything you guys do meets all those standards?
Yeah, so we work not only with the Pendulum tester, we always FEA our products. And what we see in FEA, we see in the real world as well with our Pendulum tester.
So you're able to overlay those two test results?
Yes, we do. Yeah, and 9 times out of 10, they're almost identical. And there's so much emphasis on speed to market, but speed's one thing, but having the product that is fit for purpose is another thing.
Yeah, I think it's very important now.
Extremely.
There's cars that people are using for four-wheel drives, they're family cars as well. As well as protecting the front of the car and looking good, you're mounting things like spotlights, a winch, recovery points and underbody protection to the bull bar itself. Are those things affected by the regulations as well and in the way you design a bar? Yeah,
very, very much so. There's a lot of thought goes into this. A recovery point needs to be, obviously, as you know, for soft shackles radius, you need that triangulation in the strength of the recovery point so it doesn't twist or bend on side or lateral movement. A lot of companies bolt the winch to the bar. We don't do that. We bolt to a cradle. We do a lot of FEA testing. We do a lot of pull testing. This particular one, we have a patented designed torsion bar in our winch cradle. So it allows for that torsional movement. So it actually acts like a torsion bar itself. The lights, a lot of companies drill one bolt through the bar and bolt the lights to it. Our bars are all 3-bolt pin to actually hold that load, and they're actually double skinned, so you're actually spreading that load across the bar. We've got a team, everyone's a four-wheel driver, everyone's excited and passionate about what they're doing. Everyone wants to take the bar and what we do to the next level. It's really refreshing when you work with your team and you actually produce products like this.
Yeah, I can hear that passion in the way you're talking about the product as well. And you can see it in the final result. It's a stylish looking product. It enhances the look of the car as well as protecting it. All exciting stuff. Let's go out and have a look at some of that testing.
Let's go. There's one or two in the market out there, but then they're just the Pendulum and they're a fixed weight. With this one, actually we have weights where we can weight it to put different loads in to replicate the vehicle mass. So basically what we do is we replicate the weight of a vehicle. So for instance, if the vehicle was 2.5 tonne, we'd use the weighted cylinders to achieve 2.5 tonne across the Pendulum itself. So that way, what we're doing is we're replicating the vehicle at a low speed impact, which is quite violent when you actually see it. That slow, sudden stop is what we're measuring. So we're measuring how the bar and crush can, and some instances is the chassis rail itself, how it actually absorbs, and we end up with that window or dwell timing of the G-force.
You mentioned chassis rails then, that you have to use individual chassis rails for each different vehicle you test.
So we'll, obviously when we're doing our development with the bull bars, we'll scan the chassis rails and then we will remake the chassis rail to fit the machine. So we're mimicking exactly what would be in the vehicle itself.
So the thicknesses and the materials and everything are exactly the same?
Exactly the same, yeah. So if the factory Toyota rail is 2 mil, then we make the bracket 2 mil. So if you were to undo the Tundra that we got out the front, you would see the first 6 or 8 inches would be exactly the same as this. Even down to the holes, the position, the fish plates, everything.
Okay, there's a lot of work for every different car.
Well, it is, but what we want to do is make sure that what we're testing is a true representation of the test.
Makes it all worthwhile.
It does, that's right. And we can go to market with the confidence that our product is fit for purpose.
Just looking at the structures in there in the back of the bar, and when you consider the weight of a steel bar with a winch mounted on it, driving over corrugated roads, you can see why all that bracing's there.
Yeah, so I guess the magic is really behind the bar. So all that structure in behind the bar, things like spreader plates, crush tubes, sort of keeping that chassis fixture rigid enough, but they're not too rigid where you're going to break the bar and break the chassis itself.
So there's a lot of bolts there where you're mounting the bar to the rails.
The M12s you're seeing, they're the mounting bolts for the bar itself. So that's when you get the bar on the car, you set your height, your pitch, your roll to make it fit the car. So every vehicle you fit will be slightly different. Obviously body rubbers compress over time and stuff like that. And then the rear ones are what they call pinning bolts. So once that bar's in location, you then pin the bar to the cradle. So then it locks the bar in that position. But they also serve a second purpose. They're also designed to, in an impact, shear. That then allows the slots in the bar to then work with the crush can to take some of that absorption. And that's the thing, you know, there's that fine line of, you know, safety, integration, performance, and aesthetics. So you've got to package all that into that one thing.
The big thing for me watching that is it wasn't as violent as I expected, but then after you've explained it to us, it's not testing the strength of a bull bar, it's testing how it affects the safety systems, the chassis rails, the crash cans. So 16 kilometres an hour, that's what it's doing.
If the bar is not fit for purpose, then, you know, someone's life's at risk. So we need to make sure that we meet the requirements of the ADRs.
So you're getting a product to market which looks good, does its job, and serves a purpose.
And safe.
And safe.
Safety,
Exactly,
safety,
yes.
safety, yeah.